In April of 1965, the United States quietly launched something no nation has ever flown before. It was a fully operational nuclear fission reactor in orbit around Earth. This was the SNAP-10A, the first and only nuclear power reactor to ever generate electricity in space. Until then, spacecraft relied on solar panels or small radioactive batteries, but Cold War missions were demanding far more power for radar systems, long-duration surveillance, and advanced sensors. At the heart of the SNAP-10A was a uranium fuel core enriched to about 93% uranium-235, similar to weapons-grade material, which allowed the reactor to remain extremely small while sustaining controlled nuclear fission. Heat from the reactor was carried away by liquid metal coolant made from sodium and potassium, known as NaC. This was a groundbreaking achievement. Liquid metal cooling was considered the future of high-performance reactors, and SNAP-10A became one of the first nuclear systems ever to successfully operate using sodium-potassium coolant in space. The same basic concept was being explored for large, fast breeder reactors in advanced terrestrial power plants. The heat flowed into thermal electric generators, which converted it directly into electricity, producing about 500 watts of continuous power, enough to operate high-energy electronic systems without sunlight. The satellite itself was part of a military research program designed to test long-duration nuclear power for space-based radar, surveillance sensors, and communication platforms. While SNAP-10A did not carry active spy instruments, it served as a proof-of-concept power source for future reconnaissance satellites, which would have required far more energy than solar panels could provide. Before launch, the reactor remained completely dormant. Only after reaching orbit did rotating control drums expose the fuel core, allowing nuclear chain reactions to begin. For 43 days, the reactor operated flawlessly. Then an electrical failure in the spacecraft's voltage regulation system shut it down. Engineers considered the mission a complete technical success. It provided that nuclear reactors could be launched safely, controlled remotely, and operated reliably in space. But what happened to it? SNAP-10A is still in orbit today. The satellite was placed into a high enough trajectory that it will remain circling Earth for thousands of years, slowly decaying over centuries before ever re-entering the atmosphere. It remains one of the few nuclear reactors still quietly traveling around our planet. Plans were underway for much larger space reactors capable of producing tens or even hundreds of kilowatts for orbital stations and deep space missions. But changing politics and improved solar technology ended the program. Yet, SNAP-10A had already made history, a nuclear power plant in orbit. If you found this interesting, please stay tuned for more.